I want to take a minute to go over some of the problems we did in class on Monday, October 13th. These are the more difficult problems involving work, energy, and power. The first one that we did said that we had a sled with a mass of 4.5 kilograms, and we pulled it with a given force that was 225 newtons along the snow. We have the angle given between the ground and the snow that was 35 degrees. The question is, if we move a distance of 65.3 meters, how much work does Jody do? So let's get a little bit of a visual going on here. We have a sled. It's being pulled across the snow. So the sled is moving straight across the snow, but the force is being applied at an angle. The force is applied at an angle, and we know that angle. That angle is given. That angle, I'm just going to call it theta in the diagram, but we know what it is. It's 35 degrees. So the rule is, the golden rule, you know what, I'm going to write it in gold. This is the golden rule here. The force and the distance must be in the same direction in order to calculate work. So for all this stuff, the force and the distance must be in the same direction. Right now they're not. Look, the displacement is in this direction, strictly to the right, but the force is in this other direction, angled up. We can't have that. It doesn't work. So we need to either put the distance and make it going up that way, or take the force and make it going down that way. I think it's a lot easier to take the force and make it go down that way. We can just use our cosine function. Let me show you exactly how to do that. The cosine function is already built into our equation for work. We say that work is equal to force times distance times the cosine of the angle between the force and the distance. So the force here is 225 newtons. The distance here is 65.3 newtons. And the cosine of the angle between the force and the distance. The angle between the force and the distance is 35 degrees. And if you plug that into your calculator, you should get 12,000 joules. Okay? The second question, we're given a piano. It's sitting on a plank. How much work does the person do to slide it up the plank? So first of all, the mass of the piano, it's not a mass, it's given as a force. I'm going to write the force of gravity, because that's what the force is that's given. The force of gravity of the piano is 4.2 times 10 to the third. The distance of the plank is 3.5 meters, and the angle is 30 degrees. Calculate the work done by the person sliding the piano up the plank. So here we go. We have a plank here. I'm just going to go ahead and complete the triangle. We have a plank here. The piano is being slid up the plank that direction. So that means that if the distance is in that direction up the plank, then the force must also be in that direction up the plank. But that's not what we're given, is it? We're given the force of gravity. We're given this force. We're given the force pulling the piano straight to the center of the earth. That's the force that we're given. But we don't want that. We want to find the force of gravity in this direction, in the same direction as the plane. Because remember, the rule is, when you're calculating work, you have to have both the force and the direction in the same exact direction. Both the force and the distance in the same exact direction. So we can do that. If we have the force of gravity down here, we can do our little triangle trick. I'm going to go ahead and continue this plane just to make it simpler. We can draw a line that is perpendicular to the plane and intersects our gravity vector. This is a right angle here. And because of our trig relationships, we know that this angle theta is the same as our original angle theta, 30 degrees. So we know the force of gravity right here. We know the angle theta. So that means we can find this component right here using our sine function. Let me show you the work for that. We can say that the sine of our angle is equal to the opposite, I'll call it x, this is x right here, is equal to the opposite over the hypotenuse, which is the force of gravity. So if we just cross multiply, we can cross multiply the sine of the angle times the force of gravity, and then we'll get x. So in this case it would be sine of 30 times the force of gravity, which is 4.2 times 10 to the third. And that will give you, if you plug that into your calculator, that will give you this force right here. So now we have a, change the color. Now we have the force in this direction that we've just figured out. We have the displacement in that direction right here. So we can multiply the force times the displacement, and we can get our work. Remember, work is equal to force times displacement. Okay. The next question, number 3, very similar, except this time we're one step ahead. They give us, the angle is given as 30 degrees. The force applied, the force that you're pulling the thing up the ramp is given as 225 newtons. Let's see, the distance, the height rather, the height, let me do sub h, how's that? The height of the thing is 0.28. So in this case, we're given the opposite sort of information as we were before. In this case, we're given the force up the ramp, right? It says we pull a box up the ramp at 225 newtons. So the force being pulled is 225, but we're given not this displacement. We're not given the one we want. We're given this displacement over here. We're given the height. But that doesn't help it, does it? The rule is your force and your distance need to be in the same direction. Right now they're not. I got the height going up, and I got the force going on the ramp like this. So I can't do it. You need to find the distance in this direction. But I can do that because I know that this value here is 0.28. I know that the angle over here is 30 degrees. So I can just say, well, I know sine of 30 is going to be opposite over hypotenuse. Let's call it h. I can cross multiply. H sine 30 equals 0.28. If I divide both sides by sine of 30, h is equal to 0.28 divided by sine 30. And you plug that into your calculator and you find the hypotenuse, which is right over here. So then you have a distance in the slanted direction. That's your hypotenuse that you just found. And you have a force in the slanted direction, which is given. So now that we have both things in the same plane, we can use our work equals FD formula. We don't need to use the cosine theta. A lot of people get confused. Sometimes we attach a cosine theta times the end of it. The cosine theta is what we just solved for. So the cosine theta is just in case there's an angle between the two, between the force and the distance. There was an angle, but we just took care of it. So now, because they're both in the same plane, the distance is in the plane of the angle, and the force is in the plane of the angle. We don't need to worry about the cosine because they're already in the same direction. So we just do F times D. We would do 225 times the distance that you just found, the 0.28 divided by sine 30, and that will be your work. Okay. The next one is number 4. We're riding an escalator. We're given the mass of the individual, 52 kilograms. Let's just go ahead and find the force of gravity. The force of gravity would be mass times acceleration. I'm going to plug that into my calculator. I'm going to do 52 times 9.8. So the force of gravity is going to be 510 newtons. Okay, next up we have the length of the elevator. I'll call that a distance. It's 227. And the angle is given at 31 degrees. How much work does the escalator do on the individual? So let's check out our diagram real quick. We have the escalator like that. We're given the distance of the escalator. That's 227 meters in this direction. But we are not given the force in that direction. We're given the force as just gravity. So the force of gravity is not in that direction. The force of gravity is straight down towards the center of the Earth.
For our teachers and students who are in the building, the main campus, we have to test the fire alarm for the new construction. It may be like on for 2 minutes. We will turn it off as quickly as as possible. It's going to go off in about, I'd say, 2 minutes. It'll go off. So please understand, this is a test. Do not leave the building or anything. There's no reason to. It's just a test. And it'll only last as long as we have to keep it on to test all the equipment involved, which should be a couple of minutes. Thank you.
Okay, so we're given the force of gravity, but that doesn't help me. I need the force in the direction of the plane. And in order to do that, I can use my sine function. If you're unsure as to how I derived this, this trig equation right here, you can look at the previous problem or two. If I take the force of gravity times the sine of 31, I will get this component. So you plug it into your calculator, and that gives you the force component in the direction of the plane. And I'm given my distance in the direction of the plane already. So now that I have both values in the same direction, now I can use work equals FD. So my work is going to equal my force, which is 510 sine 31, whatever that is, and multiply it by 227. Okay, hope that helps. Let's do one more. Let's do number 5 here. I don't want to belabor on this too long. We have a lawnmower, and it's being pushed. So here's your lawnmower, and here's your handle, and you're applying some force into the handle as you push it across your lawn. But the lawnmower goes this way, doesn't it? It goes straight like that. So now we have a discrepancy. We have a discrepancy between the direction of the force and the direction of the displacement. The displacement is one direction, it goes straight out here, and the force is a different direction. The force goes down like that. We can't have that. In order to find the work, your force and your distance need to be in the same direction. They either need to both be down like this, or they need to both be out like that. Easiest thing is to make them both on the x-axis. So if we draw a line like this, we know the angle. It's given in the problem. I'm just going to go ahead and write it in there instead of writing all my givens. It's 22.5 degrees. So if you look at your right angle here, you can use your cosine function to find the x component of the force here. Or you don't even need to do all that thinking if you don't want to. Your equation, work equals FD. Let's add the cosine theta onto the end of it. Here is where it's useful. It's useful in this instance where one of our forces lies along the x-axis and the other does not. I was given a question in class today. When do we know when to use the cosine theta, and when do we know when to use our really, really annoying triangle of death that everybody hates like that? Well, I'm going to tell you right now. When one of your components is in the x direction already, like the distance, and only one of them is not in the x direction, then you use your cosine, and it's easy. If they're both in weird directions, like if they're both along this plane, like the first 3 problems or so, then you need to draw your funky triangle. Okay? So because only one here is off and the other one is on the x-axis, I can just use my built-in equation here. So the force would be, let's see, I think that's given, 115 newtons. The distance is, oh, that's what they want you to find. You don't know what that is. Times the cosine of 22.5. But we're not done yet. In this case, we're given, they want us to use the power equation as well. Let me make some room over here. Let me go ahead and solve this. We know the power is equal to work divided by time. The power is given at 64.6 watts. The work we have just discovered, that would be 115 times whatever distance times cosine of 22.5. All I did was just take it from right here and plug it in for work. And the time is also given in the problem. It's given as 90 seconds. So you can cross multiply and solve for D. Your final equation for D, just to make sure you're doing your algebra right, it should be 64.6 times 90 divided by 115 cosine 22.5. Okay, you can probably hear the fire drill in the background. I'm going to stop there.